Hello physics learners. In this video we will know about equations of motion. So let me tell you a very important point that these equations of motion are valid for uniform acceleration only. Valid for uniform acceleration only. Uniform acceleration. For example, the gravitational force which gives uniform acceleration which is equals to g, which have value 9.8 meter per second square, as we know that. And if you don't, you will study later in the gravitation chapter, so for then note that. So example, gravity. And there are many examples of uniform acceleration, and there are non-uniform accelerations also, but the equation is only applicable for uniform acceleration. So let's go for first equation of motion. First equation of motion. So the first equation of motion given by Newton says that the final velocity is equals to initial velocity plus acceleration times the time interval, acceleration into delta t. The first equation may seems to be familiar because it comes from the simple equation as we'll have read before. Acceleration is equals to final velocity minus initial velocity upon time interval. We know that the acceleration, what is acceleration? The difference between the velocities initial and final times the time interval, sorry, upon time interval. From here we can easily simplify, like a delta t is equals to v minus u, and we get v is equals to u plus a delta t. Let me put in bracket, otherwise you will confuse. That's all about first equation. So let me write the value. V is equals to final velocity, final velocity, u represents initial velocity, velocity, a represents uniform acceleration. Always consider the equation of motion is only valid for uniform acceleration. So uniform acceleration, and lastly delta t, which represents the time interval in which the body had moved, interval. So friends, let me tell you one more parameter, that is the displacement. We generally represent the displacement by s. So displacement, so let's come to second equation of motion. Second equation of motion. It says the displacement, obviously s. It helps us to find the value of the displacement. It says that s is equals to ut plus half et square. T here is the same delta t. For convenience, to look simple, we write delta t as t. So it says that the displacement is equals to initial velocity times time interval plus half into acceleration times the square of time interval, that is this. So let me also write it once again so that you will be more familiar. Displacement is equals to initial velocity times the time interval plus half into acceleration, which is uniform, times the time interval square. That was all about second equation of motion. I know it's kind of bit complicated equation, but that's it. And one more thing that we will discuss its derivation in later section of the videos. So acha student, you know what's the value of this, what the meaning of this displacement? It's if a body moves from initial position say A to B. So if the body takes paths like this, so the distance is the path. The path followed by the body is the distance. And the shortest path between A and B, the shortest distance between A and B is refers to as displacement. So that is equals to S. So we consider it as S. So the second equation is, I think that it's clear. Let me put it in bracket. So let's come to third equation. Third equation, equation of motion. The third equation of motion says that v square minus u square is equals to 2as. So again, what I say that the square of final velocity minus the square of initial velocity when the body begins to move is equals to 2 into acceleration, which is uniform, acceleration times the displacement, displacement the body makes. That's the third equation of motion. So you will be quite fascinated to know that it's valid for the motion under gravity. I mean the motion which occur due to gravity. For example, this, consider this as a ground. If we throw a ball from here, obviously we will discuss one dimensional motion, we will discuss two dimensional motion in other section of these videos. So for example, if we throw a ball from here with initial velocity say u, and it reaches out there and still have velocity v, and we have this unknown displacement traveled, as because it is a linear motion, and it went from here to here, the distance is equals displacement. So we don't know the displacement, what's the displacement, but we know that the gravity exerts a uniform acceleration which is equals to g, and we also know that the value of g is 9.8 meter per second square, as because its acceleration, the unit is meter per second square. Don't worry if you don't know what is this gravity, you will soon know that the gravity is a kind of acceleration when you study the chapter gravitation. So we come to the point that we have to find this displacement, say h. Now student, the tricky, or can say the conceptual, or can say the logical part comes, that by seeing the problem, the condition, we have to find out the height. What we do is we find a most suitable equation which gonna give the answer of this problem or this solution. So after a good observation, we come to know that the third equation of motion can give us the value of h. As we know that final velocity square minus initial velocity square is equals to 2 n2. acceleration into displacement, which is h. Here the displacement is h. So the point to be considered, the gravity is in negative direction, that's why, and the motion is in opposite direction to that of gravity. So we take minus g. As we know the value of initial velocity, final velocity, g, that is 9.8 meter per second square, we can easily find h. And that's the application of the equations of motion. That's the example. Look friends, you may be thinking that the things are quite complicated, it's kind of mathematicals, and physics is all about observation thinking. But the thing is, physics can only be formulated, can be explained very well if we know mathematics. Physics is a thought, a hypothesis. In order to formulate it, to introduce it, to know it precisely, we use mathematics to shape it. So mathematics is a good friend of physics, and if we want to be a good friend of physics, we will also have to be a good friend of mathematics. So don't fear of mathematics, just know this concept, and you see that these kind of problems we can easily solve if we apply mathematics in these problems. Without mathematics we can't find the height and these velocities or the time interval, anything, any parameters of motion can't be find without using mathematics. So that's the importance of mathematics. So keep learning. Thank you.